Hi, I'm Chetan Pandranath, an assistant professor at Emory and Georgia Tech. On behalf of our collaborative team, including great students from my lab and folks from the Pillow, Miller, Dyer, and Jazayeri labs, I want to tell you a little bit about our efforts to develop a suite of benchmarks for latent variable models of neural data. Over the last decade, advances in neural interfacing have enabled a dramatic increase in our ability to record from large populations of neurons. With these technologies, we now have the opportunity to collect neural population data from an increasing number of brain areas and complex behaviors. To interpret these data, methods to estimate network states from population recordings are becoming increasingly valuable. These types of models, known as latent variable models, can be boosted by modern machine learning methods, which are adept at uncovering patterns from complex and noisy data. And the rapid pace of progress in machine learning means that more powerful techniques are constantly being developed that may also help this effort. Currently, the rapid development of new modeling techniques has created a number of pain points. For users, it's hard to compare techniques and know which ones perform well. It's also unclear whether a given approach would be relevant to that user's dataset. And it's really painful and time-consuming to adapt your data to different APIs. Then for developers, each developer has to determine the right way to evaluate their new method. They also have to figure out what the best points of comparison are. And there's a similar time-consuming process of getting others' methods to work, and hand-tuning model hyperparameters without necessarily even understanding how that model works or its best practices. So the barrier to entry right now is extremely high, which is likely preventing new techniques from being integrated into computational and systems neuroscience. Across a variety of machine learning communities, these problems have been addressed with standardized benchmarks and have yielded quantifiable progress. So think ImageNet for vision or Atari games for reinforcement learning. We hope a similar approach will yield similar progress in systems neuroscience. And with benchmarks in place, finding and comparing to the state of the art for any given task reduces to a quick search. To adapt this approach for neuroscience, we plan a series of benchmark suites to evaluate different aspects of latent variable modeling. Benchmarks will include publicly available training datasets to build models and fixed evaluation pipelines with held-out data for model evaluation. The evaluation pipeline and leaderboard will be hosted on Eval.ai, a benchmarking platform widely used in machine learning, particularly in the vision and language research communities. We'll provide code notebooks to demo dataset use and benchmark submission, and provide datasets in the Neurodata Without Borders format to ensure standardized formatting and APIs. And with the release of each benchmark suite, we'll host competitions with cash prizes for the highest performing teams. Our initial benchmark suite, due to release in March, will use electrophysiological recordings from multiple brain areas, including motor, somatosensory, and dorsomedial frontal cortices. Tasks will include random target reaching, cognitive timing, and reaching with perturbations. The goal of this first suite is to cover a range of brain areas and behaviors where neural population activity might have substantially different structure, to encourage the development of models that have broad application. We anticipate that future benchmarks that evaluate complementary aspects of latent variable modeling, such as inter-area communication, inferring stable representations from changing neural populations, alternate recording modalities like calcium imaging or field potentials, and more broadly, we anticipate that standardized quantitative evaluation can become an invaluable communication tool for our community. Again, our first benchmark suite will open in March, and we'll accept submissions through the end of the summer. You can sign up for the mailing list and find contact information at neurallatents.github.io. And if you have comments or suggestions, please reach out to me. We'd love to hear from you.